There is a place on Earth where time sleeps beneath a mantle of ancient snow. A place where the wind whispers across endless plains of whiteness, where the sky bleeds blue but offers no warmth, and where silence is a cathedral to mystery. That place is Greenland. And one quiet afternoon in the mid-2010s, it gave up one of its oldest, darkest secrets. A team of geologists, equipped with radar and boundless curiosity, scanned the surface of Greenland's Hiawatha Glacier, a frozen titan that hadn't changed its face in millennia. What they discovered made them freeze, not from the cold, but from awe. Beneath the ice, the radar traced a void. Not a crack, not a fissure, a chasm. A nearly perfect pit, yawning more than 300 meters deep and almost 20 meters across, vast enough to swallow entire cities like Paris or Washington, D.C. Its existence made no sense. There were no signs of erosion, no trace of a volcanic origin, no tectonic scars. It was as if something had punched straight through the planet's skin. And so the questions began. Could it have been an asteroid? A relic from space, plunging through Earth's atmosphere with blinding fury and shaping the Arctic's destiny in a single impact? Was this the scar of some ancient apocalypse, an echo from the deep past waiting to rewrite our understanding of Earth's climate history? To answer these questions, scientists would need more than intuition and radar. They needed quartz. Quartz, the crystal chronicle. Quartz, humble, beautiful, and omnipresent, is more than just a mineral. It's a witness. One of the most abundant materials in Earth's crust, quartz forms in predictable patterns. Its atomic structure, composed of interlocking silicon-oxygen tetrahedra, is elegant and simple. And because of that very simplicity, it's easily disturbed by violence. When high-velocity impacts slam into quartz-bearing rock, they leave unmistakable scars. Under immense pressure, the crystals deform. They develop what geologists call planar deformation features, or PDFs, fine, straight lines etched deep into their crystalline lattice. These are not created by weathering or erosion. Only catastrophic events can do this: nuclear explosions, or cosmic collisions. When scientists gathered quartz sand flushed from under the glacier, ancient grains that had lain in silence for ages, they found those scars. Quartz with PDFs, shocked quartz, a signature as damning as a bloody fingerprint. The implications were staggering. A cataclysm from the sky. If an asteroid had caused that crater, it must have been massive, over a mile wide. Big enough to make the Burj Khalifa look like a toothpick. As it screamed through the atmosphere, it would have glowed brighter than the sun. The impact would have vaporized rock, boiled oceans, and sent dust and debris flying for hundreds of kilometers. Forests would have turned to flame. The sky would have darkened, sunless, for years. And that matched almost too perfectly with another mystery scientists had struggled to solve for decades: the Younger Dryas. Roughly 12,900 years ago, Earth took a chilling turn. Temperatures plunged dramatically, especially across North America and Europe. Glaciers surged again. Megafauna vanished. Human cultures faltered. This sudden freeze, known as the Younger Dryas, seemed to come out of nowhere. Theories abounded. Volcanic eruptions, disrupted ocean currents, massive floods, but none quite fit. Could the Greenland crater be the missing link? Could a celestial object have struck with such force that it shifted the climate of the entire planet? For a moment, it seemed like everything was falling into place. But science can be cruel. Dating the crater was the next challenge. Using advanced isotopic analysis and examining surrounding sediments, researchers tried to pin down its age. The result? Not 12,900 years. Not even close. The crater was 58 million years old. The data was clear. The impact was real, but it happened long before the Younger Dryas, long before humanity walked the Earth. It wasn't the smoking gun. Not for this mystery. It was a blow to the scientists' hopes, but a remarkable discovery nonetheless. One of the largest and most pristine impact craters ever found, hiding beneath ice for eons. And just as the excitement seemed to cool, a new clue emerged. Ghosts across the continent. In sediment layers across the eastern United States, from Pennsylvania to the Carolinas, researchers uncovered a strange consistency: shocked quartz. Grains embedded in ancient soils that dated precisely to the time of the Younger Dryas. But there was a twist. There were no craters nearby. So how had quartz become shocked? The answer may lie in the skies. A new theory began to form: an airburst. Instead of a single impactor, a massive comet may have shattered upon entry into Earth's atmosphere. Its fragments, streaking across the skies like celestial arrows, would have detonated above the surface in a cascade of fire and fury. These mid-air explosions could generate the same pressure as an impact, enough to shock quartz and ignite continent-wide wildfires. This wasn't science fiction. We've seen similar events. In 1908, an airburst leveled over 2,000 square kilometers of Siberian forest in the Tunguska event. What if the Younger Dryas was triggered by a Tunguska multiplied 100-fold? The fire would have consumed vast tracts of North America. Soot and ash would have risen into the sky, blocking out sunlight. Crops would have failed. Temperatures would have crashed. It would have felt like the end of the world. Whispers beneath the ice. But Greenland's secrets weren't done. Far from the massive Hiawatha crater, scientists turned their attention to something smaller, stranger. Moulins. These vertical shafts, natural plumbing pipes within the ice sheet, funnel meltwater from the surface to the bedrock below. For years, they were considered minor features. But in 2018 and 2019, researchers descended into them literally. Dangling by ropes into darkness, they discovered that moulins are far larger and more dynamic than previously imagined. Some plunge over 100 meters into the ice. Some even deeper. And they matter. Because as they fill with water, they create slippery channels beneath the glacier, accelerating its flow toward the sea. It's like placing a giant ice cube on a layer of oil and watching it slide. The faster the glaciers move, the quicker sea levels rise. And the quicker our coastlines change forever. The final descent. Imagine standing at the edge of one, your breath misting in the frigid air. The glacier beneath your boots groaning like some ancient leviathan. And then, a vertical tunnel, framed in brilliant blue, plunging into infinite darkness. Now imagine going in. Researchers who did describe the sensation as falling into another world. Light dims. The air grows still. And the sound's not of silence, but of water thundering far below, ice cracking, whispering. The unknown waits. Epilogue. The ice remembers. Greenland's ice sheet is more than just a frozen desert. It's a time capsule, a library, a storyteller. It hides impact scars millions of years old. It carries the memory of cosmic collisions, of firestorms and floods, of warming epochs and freezing catastrophes. Beneath its surface lie clues not only to our past, but to our future. Because while the Younger Dryas may remain a mystery for now, the planet's balance still hangs by a thread. Another impact. Another warming surge. Another collapse of the Greenland ice sheet. Any of these could change everything. And so scientists continue to listen to the ice, thrilling, diving, decoding, hoping that one day, when the next abyss opens beneath our feet, will be ready. Or at the very least, will understand.